Hello everyone, my name is Tudor Rudes and thank you for watching this video. We'll explore together an automation I created that enables end-to-end onboarding and securing of Kubernetes workloads with CyberArk Conjur, which is fully integrated with Ansible Automation Platform or AWX. We streamline the process from an unprotected to a fully secured Kubernetes workload. The automation works with multiple Kubernetes flavors. It doesn't matter if you are using OpenShift, Rancher, Mirantis, you name it. We set the floor. I will try to explain what is Conjur, what are the methods which can be used to fetch secrets, the manual steps, and how we can help with this specific automation. This use case focuses on the Kubernetes native apps that need secrets delivered securely. With Conjur as our secrets management backbone, we aim to provide a unified, secure, and auditable way to inject secrets into Kubernetes workloads, no matter the platform. In order to achieve this component, this part, we offer multiple ways of Kubernetes applications to consume those secrets. So if you have an application which is using Kubernetes secrets objects, you might choose secrets provider. We'll push the secrets to the Kubernetes secrets. If you have secrets stored in a file, you can use secrets provider push to file. For example, a database which is consuming secrets from a file. By using this option, those hard-coded secrets credentials will be replaced with the path where the secrets are stored in Conjur. You might use external secrets operator or CSI driver. The bottom line is that we offer all the major methods to retrieve secrets securely for your Kubernetes environments, Kubernetes clusters. We'll focus on the first option, secrets provider, which injects secrets into the native Kubernetes secrets objects by using JWT authentication. In this scenario, you might use hard-coded credentials, API keys, passwords in your deployments. And by using secrets provider as a sidecar, just an example, those hard-coded values will be replaced with the path, the location, where the actual value is being stored securely in Conjur. For example, you have a password, DGH, on the right side, that will be replaced with the path where the secret is actually stored. The path will stay static, but the actual value can be rotated. Now, with K8s2Conjur, we automate everything. If you need to follow the manual way, as a developer or Conjur administrator, you need to manually identify the Kubernetes secrets used by the application. You need to manually onboard those secrets in Conjur together with the application identity, which is called host policy. You need to provide access to the secrets in order for your application to consume them. At Kubernetes level, OpenShift level, you need to replace the embedded secrets with the Conjur references and adjust the configuration manually in the deployment. You need also to attach secrets provider as a sidecar container. You need to create a config map which contains the configuration used by secrets provider to connect via JWT authentication to Conjur. And of course, you need to ensure that the role bindings are in place. The same strategy also applies for external secrets operator. You also need to modify an application in order to use and to work with external secrets operator. And the policies needs to be applied in that case too. This specific slide, we can see there are multiple steps which needs to be done by using the manual way. We need to enable a JWT authenticator, which is a YAML policy. This authenticator will authenticate, as the name suggests, all the requests coming from your cluster. So if there is a different Kubernetes or OpenShift cluster, that will not be allowed to even reach Conjur. After that, we need to identify and to define a host policy, which is called a workload identity policy for your specific application. We also need to grant permissions to that specific application or deployment to fetch the secrets. And of course, we need to enable and load a secrets provider, let's say as a sidecar, to your running application. All those steps require time. It's important for the JWT authentication and for the JWT authenticator to do it manually once, because if you have a cluster, you only need one JWT authenticator, and for security reasons, we suggest that this step not to be automated. Now, if we are using the automation flow, we can see that by running the K8s2Conjur framework, we achieve multiple phases, multiple steps which are very useful. In the first place, we'll scan your running application from OpenShift or Kubernetes to detect the static secrets. We'll onboard those existing secrets to Conjur together with the initial values. After that, we will create on the fly the Conjur policies and automatically onboard the Kubernetes application or workload. We provide access to the secrets automatically. We'll also patch the actual deployment in order to replace the hard-coded secrets with the Conjur references or the Conjur paths. We attach secrets provider as a sidecar. we'll create all the JWT authentication parameters, and of course, together with the airbag policy, role bindings and config maps, and everything related to Kubernetes, which can be used to provide permissions for the secrets provider to update your secrets. We split the automation in 3 phases. We can call them, we can think this is like a life cycle, and there's 3 phases. We scan, we onboard, and we secure. We initialize the connection by using REST API to Conjur, and also towards the OpenShift or Kubernetes API access point. We'll do the discovery of the targeted app from Kubernetes. We check what kind of secrets are being consumed, what if maybe those secrets are mounted, or those secrets are used in Kubernetes secrets object. We list and decode the secrets initially used. We patch all of them with the annotation specific to Conjur. We generate prefixed Conjur variable names in order to avoid any kind of confusions. For example, if you have an application which is called database1, the secret will have the path name database1/password. We'll update the Kubernetes secrets with the Conjur map annotations, like linking them to the Conjur variables. We'll authenticate and onboard the identity, the Kubernetes identity to Conjur, and provide access to the secrets. We upload the initial values to Conjur. We'll inject the secrets provider as a sidecar. We'll patch the deployment. We'll also configure the JWT authentication, and everything packed together will be done automatically by relying on Ansible. This architecture does a couple of things which I explained in the previous slide. But the main idea is the following. We leverage on the REST API, so Ansible will be able to connect to Conjur, also to OpenShift. The repository of the project, I will make it public, so you will be able to test it in your own environment, in your own test environment. And by the way, for security reasons, all the sensitive informations which are required for the authentication part will be stored in Conjur as well. Because between Ansible and Conjur, we have already a plugin which can be used to fetch those secrets. So for example, if you have Ansible and it needs to connect to OpenShift, it will require an OCP token, the bearer token, but instead of storing that token in actual Ansible, it will be stored in Conjur and fetched securely by your Ansible node. And we can start the demo and watch what our automation can do. With a deployment which contains a Postgres database and the client which is connecting to the database by using Kubernetes secrets. If we expand the deployment, we can observe the service account, the type of the container, the port, username, password. In the same time, we can also check the secrets, which will be used to store those informations in OpenShift or Kubernetes in the Kubernetes secrets object store. So we have a username, a password, and a database name. Everything is in clear text. Those informations, secrets are hard-coded in the deployment. At the end of the automation, this unprotected application will be fully onboarded and secured by using the automation together with Conjur and Ansible. Let's deploy the application. We can choose out the namespace. It will be deployed into the automation minus namespace. We apply the role bindings. We apply and we create a service account. And finally, when we switch to, in my case, I'm using OpenShift. Under the deployment, we can see that everything is running as expected. We have the Postgres as a init container and the DB client, which is connecting to my database by using the provided credentials. I also put it in the output so everyone can check this simple application and to see that everything is running. And if we move to the secrets part, we'll see the Postgres secrets here, which contains the values presented in the deployment, like the database name, the database password, and the database username. The application is running, nothing is done from automation point of view at the moment. And then we can move to the next stage and spin up the K8s2Conjur automation from Ansible automation platform. As we can observe, I'm connected to my Ansible automation platform. It also works with AWX, you name it. From the templates area, I already done the configuration. I follow the guide I will share with you, and I only need some simple details, like what is the service account of my application. That's very simple. If we go back and check the deployment, my service account is called 2025 Postgres -SA from service account. So we can fill those informations. The namespace is Tudor automation -ns. The deployment name, let's double check. So the deployment name is called Postgres. And authenticator, which I already defined. This authenticator will validate any calls done by the OpenShift cluster together with the automatic generated JWT token. That's it. Only 4 fields needs to be completed. The automation started. We can check actually the live what happens with our application. And as we can observe for the moment, the Postgres has only 1 container, and when the automation is finished, as you can already see, everything is already done. So I onboarded the application in Conjur, created the corresponding secrets at Conjur level, onboarded the initial values like my user, my password, patch the deployment, done rollout update, attach secrets provider, configure JWT authentication, and if we move back to the Ansible automation platform, we can observe in the final output all the tasks which are done. So I onboarded the deployment in Conjur. We discovered 3 secrets which are already loaded in Conjur. We generated the policies. We attached secrets provider and patched the Kubernetes deployment. We loaded the role bindings, and that's it. We can double check. If we move to the Conjur Enterprise and let's do a refresh, we can already see the application is onboarded. So it contains the namespace and the service account. You can check everything from the GUI as well. And if we move to the secret, as I mentioned at the beginning of the demo, there will be a dedicated annotation automatically loaded. So I'm using the deployment name minus onboarding secret /db name /db password /db username. So those are actually the same annotations used in my deployment in the beginning. So if we can do a cut on the secrets, YAML, see here, db username, db password, db name. I also tested automation with 50 secrets used by the deployment. And because I'm admin and for demo purpose, I can also check that the values were also onboarded. So I can see my pass. I can see the other value, which is called db name, which is my app db. I can also check the username, my user. If we do like a parallel, we can see that the initial values were loaded in Conjur, together with all the policies, all the grant access policies, plus everything related with the JWT authentication. If we switch to OpenShift, and if you go to the deployment and to the secrets, now if you remember, we didn't add the Conjur map before. And now, at the lower part of the screen, we can observe that for the Conjur map, we already done the binding. So the deployment, instead of having in the actual YAML file the database name, it will have the path, the location from where the secret is being stored at Conjur level. Same applies for the DB password and username. And to test that everything is running, we can do like a manual rotation of the secret live. So let's choose to change the value for the password with Tudor special password. This value will be updated live at Kubernetes level, OpenShift level. If we move back, the rotation is already done and the application is up and running without any issues. We can check also from the logs perspective. We can see the secrets provider was attached to my initial application and is successfully connecting to Conjur and fetches the secrets, and those secrets will be used to update the object store, the Kubernetes secret object store used by my Postgres database. It's easy, as you can see. You can also check the logs. If you want to have the same environment and to test it on your side, you can access my repository. Everything is explained, all the configurations. You can press on getting started, deploy the Kubernetes automation, press expand. Those 3 parts needs to be done only once manually, and after that you just go to templates and press run or launch template. From jobs perspective and also for demo purposes, you can also verify all the actions which were done by the automation. We can also see the recommendation. It checked and it discovered there is a secret called Postgres secrets. This is a candidate for the onboarding, And all the steps are presented in the playbook. For security reasons, you can disable them completely, but for debugging, I kept them in the playbook. Also, in order to have everything working, you just need to have the firewall, the network connectivity part in place, so Ansible can reach your Kubernetes cluster, as well to reach the Conjur instance via 443. And from configuration point of view, is nothing special. In order for Ansible to communicate with your Kubernetes cluster, OpenShift cluster, you just need to install a module, which is called Kubernetes core module. And pay attention, I will start creating also other types of integrations, or to use different other methods to fetch secrets, like external secrets operator. I will also use the stackater, the reloader. The devs know about this repository. It's used to do rollouts without affecting a lot the lifecycle of an application. For the guides, for example, if you press on the secure connection between app or Conjur, you can use your own deployment in OpenShift with different types of secrets. If you just want to run a simple demo, you can use my own demo. It's present at step 4. Everything is explained. All the policies which needs to be loaded once are in the repository. And yeah, that's the automation. We reduce the time of a couple of hours or days to just under 40 seconds.